if we had the two probabilities 0.2 and 0.8, you can see these add up to 1. And this would be a binomial distribution because there's only two probabilities. And so to do the complete distribution of this binomial, which we'll do in a minute, we actually need to use Pascal's triangle first. Remember, Pascal's triangle starts with 1 at the top and it's got 1 on all the sides. And then from there, we do the sum of the two numbers above. 1 plus 1 gives me the number below, 2. So we have numbers on all the sides. And this 4 tells us we need to be in the 4th row of Pascal's triangle. So you can see here we get 1 and 2 give us 3, 2 and 1 gives us 3, and we have 1s on both sides. This tells us we have to be in the 4th row, but Pascal's triangle starts in the 0th row, row 0. So we're only in the kind of the 3rd row right now. So we need another row, starting with the 1, 1 just on all the sides. Add the numbers above, gives us 4. Here, 3 and 3 gives us 6, 4, and then 1. So here, we're in the 4th row. So that's what we use. We use the 4th row because the degree on our binomial is 4. These numbers give us the coefficients on our terms that we'll write. Let's move this down and make a lot of room. And so we have how many terms? The same number as in our row. 1, 2, 3, 4, and 5. 5 terms. So we write out the product of our probabilities 5 times, and I'll copy and paste it. Make more room. Let me move this. The purpose of using Pascal's triangle is to give us the coefficients out in front of these numbers, which we got from the row 1, 4, 6, 4, and 1. That's why we use this. These are all added. And the last thing we need to do is add the exponents. So we start with an exponent of 4 on the first term, the same degree or same exponent as the binomial. And so we start with 4 and then go down by 1 each time. So we get 3, 2, 1, all the way to 0. Next, we write the degree of 4 starting from the other side and go down by 1 each time in the opposite direction to 0. And that's pretty much it. So try to remember those steps when you do a binomial expansion. Those are the hard parts. We could simplify this more, but that's the easy part. Simplifying this, we could see anything to the power of 0 is 1. And we only have that here and here. And we could rewrite this. What would we do with this? We could do something like, what is the probability of having 3 of these events and 1 of these events, for example, out of 4? We would find that here. We have 3 events, 0.2 and 1 on 0.8. And so just taking this part would be that probability, or we could use this for other things. For example, what would be the probability of having at least 1, so at least 1 greater than or equal to 1 of these probabilities? Well, that's everything from this, where we have 1 on 0.2 all the way up. So we would add each of these terms to the first one. So we have at least 1. We have 1, 2, 3, 4 of them. The other way of doing an at least question is probability of 1 minus this one. So if we did 1 minus whatever this was, that would be the same thing. All right,